you're new here, please consider subscribing. In this video, we are going to solve this problem that says if x equals tan theta minus sin theta and y equals tan theta plus sin theta, then you prove that x squared minus y squared, the whole thing squared, is equal to 16xy. So how do we approach this? So the idea is simple in this case, just to show you that math doesn't suck. It's that you only have to think about how, in the easiest way possible, you solve that problem. So in this case, we can look at these two as simultaneous equations that we can solve together. For example, if this is 1 and this is equation 2, then we consider this is negative and this is positive. If we add, this will go out and that eliminates sine, and then we end up having only a tan in terms of xy, and that's basically what we are going to do. So we will say if we add 1 plus 2, that results in 2 x plus y being equal to 2 tan of theta, and so therefore tan of theta is equal to x plus y everything over 2. So this is what I think I consider as going to be the best, easiest approach to proving this. And again, we can say if we subtract 2 minus 1, 2 minus 1, so we can see that if we subtract that, then this equation minus that, then that would be kind of like y minus x is equal to, so this will go off, and so that will be minus sine, which goes to 2 sine of theta, and so from this we can have that sine of theta is equal to y minus x everything over 2. So now we have these two equations, which I can call star, and this as star 2. So we are looking of ways of eliminating these these thetas, or the theta, the variable theta, out of these two equations. So, and what we are going to do in that case, we are going to refer to the standard trigonometric equation, which is known to almost anyone, that is sine squared theta plus cosine squared theta is equal to 1. This is a known identity, which is almost the first equation that is proved when it comes to trigonometry. So in that case, we can see that we have sine, which is already here, and we don't have cos, but we have tan. But we know that if we divide sine over cos, that goes to tan, and so what you're going to do is to make sure that we divide throughout by sine, because that would give us cot, which cot is in terms of tan. At the same time, on this side we have 1 over sine, and so which sine we already have, instead of dividing throughout by cosine, and again we have to find cosine, what it is. So I'm going to say divide all sides by sine squared, so that will be sine squared plus cos squared theta everything over sine squared theta, and this is equal to 1 over sine squared theta. And so we can see that here we have 1, and this is cot squared, so but cot squared is 1 over tan squared theta. This is going to be equal to 1 over sine squared theta. And so from here we can see that we have 1, and then we have 1 over tan squared, but tan is already here, we just need to square it and take its inverse, and so this is going to be like 1 over x plus y everything over 2, and then squared, and this is equal to 1 over sine squared, but sine is already here, and so that is y minus x over 2 everything squared. So all we need to do here is to remove these fractions by multiplying throughout by this and that, by product of this and that. And so or I could first of all eliminate these the denominators here by first of all looking at like 1 plus, if I square that, the 4 will go up, and so that will give me 4 over x plus y squared, and this is equal to also 4 over y minus x, everything squared, if we open up this denominator. And so in this case, we can multiply throughout by product of this and that. And so this one is going to give us x plus y squared into, y minus x squared plus, this is going to be 4 by that, so it's going to be 4 into y minus x squared is equal to 4 into x plus y, everything squared. So from here we observe that a square of y minus x can be the same as x minus y, since it is a square, or we can just alternate these two to be y plus x. So I can rewrite this as y plus x such that we have this squared into y minus x squared. Then this is going to be taken this side, and then I have 4 into x plus y squared, then take off 4 into y minus x, this squared. So now we need to simplify this further. From this, we can see that this is a difference of two squares, which basically can be rewritten as y plus x to y minus x. The whole of this is raised to power 2, and then I can factorize out also 4 on the right hand side, and then that means this gives x plus y squared minus y minus x squared. So again, we can rewrite this in terms of either x first or y first, or y first or x. The whole thing is about their squares. Okay, so in this case, this turns out to be y squared minus x squared, but this is into power 2, and again we can have 4 into in this case these are squares, so like I mentioned, you can put this first, y plus x, or we can put this first as x minus y, being a square, doesn't matter. So again, I would say that this is a difference of two squares, such that we have this first bracket plus the second bracket, or so we will say that this is x plus y, then plus y minus x, that's the first bracket, into the second bracket, which is this minus that, so it's going to be x plus y, then minus y plus x, and so that's what we have. And so again, this can be rearranged like this first and this last, because that whole thing is to the power 2, it doesn't matter, so that we can have as x squared minus y squared squared. The reason we do this because this is what we have as to be proved, but it doesn't matter anyway, and this is equal to 4 into this x goes with that, and then this is 2y, and then we can see that in the brackets here what survives is an x at the end, and this x, so the y cancels, and so that multiplies by 2x, and so this means we have x squared minus y squared, everything squared, and this is equal to 4 by 4, that is 16 x, y. And so this is our required proof. Thank you so much for watching. Please consider subscribing and leave a comment below or any idea on how you would quickly solve that. Thank you.